Hi everyone. Today we're going to study walk, circuit, and path in the graph. Let us start by defining walk. Let G be a graph and let V and W be vertices in graph G. A walk from V to W is a finite alternating sequence of adjacent vertices and edges of G. Thus, a walk has the form V sub 0, E sub 1, V sub 1, E sub 2, up to V sub n minus 1, then E sub n and V sub n, where the V's represent vertices, the E's represent edges. V sub 0 equals V, V sub n equals W, and for all I equals 1, 2, up to n, V sub I minus 1 and V sub I are endpoints of E sub I. The trivial walk from V to V consists of the single vertex V. Now let us define closed walk. A closed walk is a walk that starts and ends at the same vertex. Let's define circuit. A circuit is a closed walk that does not contain a repeated edge. Thus, a circuit is a walk of the form V sub 0, E sub 1, V sub 1, E sub 2, up to V sub n minus 1, then E sub n, then V sub n, where V sub 0 equals V sub n, and all the edges are distinct. Let's define simple circuit. A simple circuit is a circuit that does not have any other repeated vertex except the first and last. Thus, a simple circuit is a walk of the form V sub 0, E sub 1, V sub 1, E sub 2, up to V sub n minus 1, then E sub n, followed by V sub n, where all the edges are distinct and all the vertices are distinct, except that V sub 0 equals V sub n. Let us define path. A path from V to W is a walk from V to W that does not contain a repeated edge. Thus, a path from V to W is a walk of the form V equals V sub 0. This V sub 0 is followed by E sub 1, then V sub 1, E sub 2, up to V sub n minus 1, then E sub n, the last, the vertex V sub n. This V sub n is the W, where all the edges are distinct. Let's define simple path. A simple path from V to W is a path that does not contain a repeated. Thus, a simple path is a walk of the form V equals V sub 0, followed by E sub 1, V sub 1, E sub 2, up to V sub n minus 1, then E sub n, the last vertex, V sub n, and this V sub n equals W, where all the edges are distinct and all the vertices are also distinct. Here is the summary table for the walked, closed walked, circuit, simple circuit, path, and simple path with respect to repeated edge, repeated vertex, or starts and ends at same point. Let's see this example. In the graph below, determine whether the following walks are paths, simple paths, closed walks, circuits, simple circuits, or just walks. Letter A, we have this walk. V sub 1, E sub 2, V sub 2, E sub 3, V sub 3, E sub 4, V sub 4, E sub 5, V sub 2, E sub 2, V sub 1, E sub 1, V sub 0. If we track this walk, we will have a graph that looks like this. This graph starts at vertex V sub 1, then goes to V sub 2 along edge E sub 2 and moves continuously. At the end, it goes from V sub 1 to V sub 0 along E sub 1. Note it that the vertex V sub 2 and the edge E sub 2 is repeated twice and starting and ending not at the same points. Hence, the graph is just a walk. Letter B, V sub 1, V sub 2, V sub 3, V sub 4, V sub 5, V sub 2. Let us try to track this graph, and it is like this. From V sub 1, V sub 2, V sub 3, V sub 4, V sub 5, V sub 2. In this graph, vertex V sub 2 is repeated twice, and no edge is repeated. Therefore, the graph is a path. Letter C, V sub 4, V sub 2, V sub 3, V sub 4, V sub 5, V sub 2, V sub 4. Let us try to track this walk. We will have a graph that looks like this. It starts with V sub 4, V sub 2, V sub 3, V sub 4, V sub 5, V sub 2, V sub 4. Vertices V sub 2 and V sub 4 are repeated, and graph starts and ends at the same point V sub 4. Also, the edge E sub 5. This is the edge E sub 5. Connecting V sub 2 and V sub 4 is repeated. Therefore, the graph is a closed walk. Letter D, V sub 2, V sub 1, V sub 5, V sub 2, V sub 3, V sub 4, V sub 2. When we graph the track, it becomes like this. This is V sub 2, goes to V sub 1, V sub 5, V sub 2, V sub 3, V sub 4, V sub 2. Vertex V sub 2 is repeated, and the graph starts and ends at the same vertex V sub 2. No edge is repeated. Hence, the graph is a circuit. Letter E, V sub 0, V sub 5, V sub 2, V sub 3, V sub 4, V sub 2, V sub 1. When we draw the graph, it becomes like this. It starts with V sub 0, V sub 5, V sub 2, V sub 3, V sub 4, V sub 2, V sub 1. Vertex V sub 2 is repeated, and no edge is repeated. Therefore, the graph is a path. Letter F, V sub 5, V sub 4, V sub 2, V sub 1. Let's draw the graph, it becomes like this. It starts with v sub 5, v sub 4, v sub 2, then v sub 1. Neither vertex nor edge is repeated. Therefore, the graph is a simple path.